simulation laboratory developed by College of Engineering, Pune. Go to electrical engineering section, wherein you will find first lab as sensor modeling and simulation. Click on to the first experiment, that is characterize the temperature sensor RTD. Now there would be aim, pretest, theory and procedure. We want you to read it first and then go to simulator. Once you click on to the simulator, the page will appear, which is in the form of the experimental setup and a control panel. Now you have to select the values or the data from the control panel. For example, for RTD, I want to test material platinum. The range is given as -200 to 850, and the R0, that is resistance at 0 degrees Celsius, I have selected 100 ohm. Then you will have to get the temperature from here. The temperature is 398 degrees Celsius. You will calculate the value of resistance based on the formula, and that value is 253.23. If your value is correct, you will have to submit. If the value is correct, it will indicate you as correct. Then get new temperature 397 degrees Celsius. For 397 degrees Celsius, the answer is 252.845. We'll say submit. The answer is correct. Then we will take one more temperature, which is 738 degrees Celsius. For 738 degrees Celsius, the reading is, or the answer is 384.13, and you submit this. Once you submit this, level 2 will get switched on. Now if you go to level 2, prior to that you can see how the graph looks like. The graph will look like this. So this is the relation between temperature and resistance in ohm. You can close this graph and then go to level 2. Now once you go to level 2, this is the experiment for checking the dynamic characteristics of the RTD. You have already selected material as platinum, so the same material will come. You will first select bare material. So the time constant is 1.17. Click on to OK. Then if you select with sheath, suppose you have a protective cover to that as indicated in the diagram, you will find that you will have to select the material for the sheath. For example, I have selected SS304 as a material and thickness is 1 millimeter. The time constant has gone up to 413 seconds. Now if you still want to continue with the dynamic characteristic, and if you select a thermo well, looks like this as shown in the diagram. Select the material of the thermo well, which is SS304, and again suppose the thickness is 2 millimeter. Then filling material, which is to be inserted in between the gap of sheath and thermo well, and the material which we have selected is MgO powder, which is a standard thing. The time constant has gone to 14.15 seconds, and if you plot this, you will find that how the time constant is changing with only bare element, only with sheath, and this is with thermo well. The maximum time constant is for thermo well. Similarly, you can perform experiment for other materials and with R0 values.